right, so like I was saying, there's two types of data. Data, data that's continuous and data that is discrete. Now, let's use a little bit of vocab knowledge to try to figure this out before I tell you what it means in math, okay? When you hear the word continuous, what do you think about? Something that keeps going. Is it interrupted? No. So this is data. You don't have to write any of this. This is data that is not interrupted. Two R's or one R? I'm a horrible speller. That's okay. I can do math. I cannot spell. Okay, so data that is not interrupted. So if continuous is data that is not interrupted, what do you think discrete is? It's the opposite, right? Something that can be interrupted. Okay, so let's go ahead and try to figure this out. A graph consisting of distinct unconnected points. So we got to decide which one is which. Or a graph that can be traced from left to right without picking up your pencil. So which one do you think is continuous and it does not get interrupted? So read it again if you need to. It says a graph that can be traced from left to right without picking up your pencil. We're trying to figure out continuous, which is the data that cannot be interrupted, that is not interrupted. Or a graph consisting of distinct unconnected points. You need to go to the back. A graph that can be traced, because if it can be traced, do you have to pick up the pencil? Do you have to pick up the pencil if it can be traced? No, you don't. Thank you, Dornisha. No, you do not. If you can trace something, if I write my name and I want to trace it, right? Do I pick up the pencil when I do the Z? No. Do I pick up the pencil when I do the L? No. The U, the L, the M, or the A? No, I didn't when I did each individual point, right? Yes. I already sent somebody, Miss Medina. What about if I write it in cursive? Which one is discrete and which one is continuous? The cursive is what? Continuous, right? Because you're not supposed to pick up the pencil when you write on cursive, right? But when you write, when you print your name, do I pick up the pencil? Yes. So this would be what? Continuous, and this would be discrete. I'm still tracing, right? I can trace both of them, but on one, what am I doing? I am not picking up the pencil. So this is a graph that can be traced from left to right without picking up your pencil. So let's go ahead and write that over here. And let's write down that that type of data would be what? Continuous or discrete? Talk to me. Continuous. Very good. So let's write that over here. Continuous. Which means the other one would be discrete, correct? All right, so this one is unconnected points. One doesn't have to do with the other, so let's glue those two. Yay? All right. So once we've glued the definitions, let's go ahead and do the examples because that's the easiest one. Oh. I'm sorry. I'm sorry. This needs to go down. Sorry. Take it out really quick, really quick, really quick. And go over the, put it on top of what you wrote, if you wrote with me like pencil. I'm sorry. My bad. My bad, my bad, my bad. Because it says not have fractional pieces. I'm sorry. No, I didn't. I wanted to give my B2 G8 a hard time. That would be you guys. Yes. That was cute. Oh, that's us. Wait a minute. All right, I'm sorry. So that means that this is unconnected points. That would be discrete, right? So it's the other way around. I'm so sorry, guys. So let's put it over here. Discrete. And then that one is continuous. Sorry. All right, so we're going to put the graphs in the example. If it's unconnected points, would you pick A or would you pick B? A or B? A. That's definitely unconnected points. Very good. So let's glue that right there. And this one is right. So these one are unconnected points. And then the other one needs to go at the bottom. Guys, 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 let's go. All right, so this is what I mean by you can trace it. Can you get your highlighter and go from beginning to end of the graph without picking up your point? Yes, you can. But in this one, you cannot because you got to jump from here, to there, to the other one, to the other one. Okay, guys, when you're talking, you're not paying attention, correct? All right, I'm just saying. That snapshot is coming. Are we going to have what? Yes. What is domain? What is range with graphs? And real life situations? Yes. All right, so let's go ahead and write down the domain for that first one. What's the domain for this one? Well, it's a lot easier if you do an X and a Y table. All right, -1 and 4? -1 and 4. 0 and 2. 1 and 0. 2 and -2. And a 3 and -4. All right, so what's the domain? Your x's, right? Your domain would be your x's. So that would be -1, 0, 1, 2, and 3. Now your range would be your y's. So start with the smallest one. -4, -2, 0, 2, and 4. Yes? We got it? No? All right, let's do the next one. Domain. Can I restrain? Yes, because it has those dots at the end that tells me that it ends, right? So from what to what? Negative 3 to positive 3. So negative 3x, positive 3, crocodiles eating the same way. What about the range? Can I restrain on both sides? Yes, I can, right? Because it stops. From what to what? From negative 3 to positive 4. So negative 3y, positive 4, crocodiles eating the same way. Yay? All right. So now what we got to do is we got to decide out of those little things that you have over there, these are everyday life things. We got to figure out which ones are continuous and which ones are discrete and you cannot cut in half. Because these ones are the ones that you cannot cut in half, right? Can you cut a soap bar in half? Yeah, can I go to the store and buy half a soap? No. They're gonna look at me like I'm crazy. They're gonna tell me, lady, you need to go to the Looney Tune because I can't sell you half a soap bar, right? You can't do that, can you? All right. So let's see. We got to figure out which ones you can cut and which ones you cannot, because we're not gonna cut them all. No, we cannot cut it. Not all of them. All right. So let's start with the ones that you cannot absolutely divide in half. All right? Can you divide the number of gift cards in half? So this is your gift card, right? And it's plastic, right? Have you seen them? They're plastic. They look like a debit card, right? So can I say, hey, Janita, you take half and Dornisha takes half. And we cut it and I give half the plastic to Dornisha. No, right? All right. So this one cannot be cut. I cannot what? I cannot cut people. I'll kill them if I do. What else? Number of dogs. Very good. I can't cut them. Or I'll kill them. Laptops. Very good. What else? Number of tickets. Good job. I cannot cut the number of minutes. Can I? Yes, I can. Say that again. Movie rentals. I cannot rent half of a movie. I can't watch it if it's half of it. No, but you still have the whole movie, right? You cannot rent half of the CD. It won't even play. All right. So, what about, is there anything else that we cannot cut? Can I cut the number of minutes? Yeah, I can say that I work for 3.5 minutes, right? Can I say that I work for 3.5 hours? Yes. Can I say that I got 3.5 gallons? Can I say that I walk for 3.5 miles? Can I say that I work for 3.5 weeks? Can I say that it's 3.5 degrees? Let's glue. Can you cut it? Ask yourself, can you cut it in half? If it's no, then it's discrete. If it's yes, it's continuous. Let's get to work. glue and talk, glue and talk, glue and talk. Shh. All right. The people that got the pizza, go ahead and get it and start eating. Next time, put them in the refrigerator if there was space. Did you check? Are you sure? Stop, stop. The Jocelyn, the money, it's on the back on a white box. Hey. Put this in the notebook. Put this in your notebook. And let's go ahead and do this. Yes, everything goes on classwork. Unless it's exit ticket or class opener, right? It goes on classwork. Or class openers, yes, thank you. I don't think I have any more. There's some paper towels over there. And if you ran out, there's more paper towels over there in the closet. All right, 1, 2, 3. 1, 2, 3. Everything is classwork. Eyes on me. Let's go ahead and start. Shh. All right, find the domain and range of coordinates and decide whether it is a function. All right, what's the domain? The smallest one first. -5, 0, and 2. Very good. What's my range? Hold on. This has a really bad glare. All right, -3, 6, 7, and 8. Very good. That's a 6, I'm sorry. All right, is it a function? Oh my God. There's 2 -5, so that's a no. We want to be the first one, regardless of if we're wrong all the time. I'm just saying. All right, what's my domain? Negative 5, negative 1, and 0. Very good. All right, what's my range? Negative 5, 4.5, 6.8, and 7. Is it a function? No, it has two zeros, right? So that's a no. All right. Shh. So for this one, I got to do my x and my y table so that I can do the domain and the range. All right, that first point, that's the 0. Do you see the x? This is the y, and that would be the x. That's the y, and that's the x. So it's the first quadrant only. I'm just highlighting my x and my y so that I don't get confused, right? All right, so this point, 0 and 1, 2, 3, 4, 5, 6, 7, and 8. That's your y-intercept, correct? That's 8, that's 6, that's 4, that's 2, and that's 0. So this one would be 1 and 6, 2 and 4, 3 and 2, and 4 and 0. I'm just looking for the coordinates of those points. Is everybody with me? Yes. All right, what is my domain, babies? 0, 1, 2, 3, and 4. Is it a function? Yes, none of those numbers. Karen's got it. None of those numbers repeat. All right, so what about the range? 0, 2, 4, 6, and 8, right? All right. Domain. Domain. Come on, guys. From 0 to 4. So 0, x, 4, right? Range? 1, 2, 3, 4, 5, 6, 7, and 8. Is it a function? Yes, most definitely. The graphs ones are the easiest one, too. Oh, this one's real easy for domain and range. What's domain? Can I constrain? No, it has arrows on both sides, right? So all real numbers, negative infinity to positive infinity, or all real numbers. And then what about the range? Can I constrain? No, it has arrows. So what would be? All real numbers. It is a function. Now, is it discrete or is it continuous? Continuous. If you can you trace it without picking up that highlighter? Yes, you can. So it would be continuous. I don't want to write it, so I'm just going to highlight what it is, okay? Because I don't want to write it again. I'm a little lazy like that. I call it working smarter instead of harder. There you go. Alright, so let's do my x and my y's, because obviously this graph is what? Can I trace it? Can I trace it without picking up my highlighter? No. So is it discrete or is it continuous? Discrete. What about this one? Can I trace it? Yep, so what is it? Continuous. Can I trace it? So continuous, because it continues. You don't have to pick it up, right? You don't have to pick it up. So that was easy. All right, let's do the domain for that one. 1 and 5. 3 and 5, 4 and 2, and 6 and negative 2. All right, so what's my domain? 1, 3, 4, and 6. What's my range? Negative 2, 2, and 5. And I don't have to repeat, right? All right, is it a function? Yes, the elements of the domain do not. Now, the range does repeat, but that's okay. So that would be a yes. All right, can I restrain? Yes, because it has those dots, right? So from negative 5 to positive 6. So negative 5, x, positive 6. Talk to me about inequalities. Less than or equal to. But this one would be less than because it's an open circle, right? All right. Let's do range. No. You start with the smallest one. From negative 6 to positive 2. All right. Talk to me about less than or equal to, right? Does it include the negative 2? The positive 2, I'm sorry. Yes, that's a solid line. Does it include the negative 6? Yes, that's a solid line. That one only affects the domain, not the range. All right, so less than or equal to, less than or equal to. Is it a function? Does it pass the vertical line test? We still do not know what a function is, babies? Because that should be like a chorus response. Like everybody should be telling me yes. Because that's probably like the easiest thing you will ever do in Algebra 1. Is it a function? Is it not a function? That's it. That's as easy as it gets. All right, is that a function? Yes. Let's do the domain. Negative 5 to positive 5, and it has circle dots, so it includes both of them, right? What about range? 0 to 5. Very good, and it includes both of them. Good job. Are we good with this? Alrighty, let's go to the back. Alright. Can you trace it with your highlighter? Yes. So is it continuous or is it discrete? Continuous. Can you trace it with your highlighter? So continuous or discrete? Can you trace it? No, so this would be discrete. Is it a function? Yes. Is it a function? Is it a function? Yes, there you go. We got it. You just get a little shy on me. I don't understand. I'm not that mean. Alright, what do we got? 2 positive 2, right? And that's why it has that dot, that sorry, I got tongue-tied. That's why it's got that point in there, so you know that it is a what? Is it a 2 or is it a 4? It's a 4, thank you. Y, the second coordinate is what? It's y, and we're looking for x's. So it's from negative 2 to 4, all right? Negative 2 to 4. Talk to me about inequalities. What about a negative 2? Less than, but then this one would be less than or equal to. All right, what about the range? 0 to 2 to 2, right? 0, but then talk to me about inequalities. So does it include the 0? Really? Is it a shaded circle? No, so it does not include the 0, but it does include the 2. The 2. All right, can I restrain on the domain? No, I can't. So all real numbers are from negative infinity to positive infinity. Can I restrain at the top? But can I restrain at the bottom? No, so that would be from 3 to negative and not positive, negative, right? Going to Hades. Going down. Yeah. So from negative, I'm sorry, not negative, to negative infinity. All right, this one would be x and y, right? All right, this point, negative 2 and positive 2, negative 2, positive 2, 3. This is the negative 2 and 2, right? 1, 2, 1, 2, right? All right, 0 and 1, 2 and negative 1, and then 1, 2, 3 and 3, right? It's just hard to read, but the one on the snapshot will not be hard to read, so don't worry about that. It's just my raggedy worksheets. All right, tell me the domain. There we go. Negative 2, 0, 2, and 3. And then give me the range. Negative 1, 1, 2, and 3. Now, you really don't have to write them in order, but it's just a lot easier if you do. Because usually the answers will be in order. They won't be like all over the place. All right. We're not going to sketch. I really just want to do this. Graph the functions. Is the domain of the graph discrete or continuous? And find the domain and the range. Okay, what is the domain? Which is what? Bags. All right. Can you cut a bag? You can? Well, if you cut it, can you use it? All right. So can you cut a bag? No. Technically, no, right? Technically, no. So is it discrete or is it continuous? It's discrete. You can cut it, right? It's 1 bag, 2 bags, 3 bags, 4 bags, right? So it would be discrete. What about the hats? Can you wear half of a hat? No. So that would be what? Discrete. Yay? All right. That's all I want to do on this one. Just discrete and continuous. Okay, the number of cereal bars. Is it continuous? Can you go and buy half of a cereal bar? No. Discrete. What about the time? That is continuous, right? Because you can do 2.5 seconds or whatever it is that you need to do, right? All right, put that in classwork. We're done with that one. All right, you know what I need? You know what we need to do? Remember that reasonable domain and range worksheet that we started, but we didn't do discrete and continuous? We need that. No, this one. But we've done that one, we just haven't done the discrete or the continuous part. Yay? Yeah, we've done it, but we haven't done the discrete and continuous part. So we got to do that. All right. Let's go to our worksheet for cheat sheet for a second, because we're going to add something to the cheat sheet. I'm giving you permission to add something to it. Jocelyn, what you needed? Yeah, go. You want to go get the drinks, right? Yeah. Do you know where they are? Teacher's lounge. Refrigerator. Look for a basket, a black basket. All right. So All right. So let's talk about the discrete. The discrete is what you can cut, right? You can count one. It's when you count. So 1, 2, 3, 4, right? And continued is like opening the faucet and just let it what? Let it flow, and it just keeps on. It continues to just go pour, right? All right, that's the difference. So then you have data that is discrete, right? You see how the lines are not connected? Then you have data that is continuous, right? So that means that you can actually pick up the highlighter and go through that whole line or curve or whatever it is and not pick it up, right? This is what we need to add. For discrete and continuous, to figure out if a function is discrete and continuous, you only need to take a look at the domain. So let's add that in. Only look at the domain. Maybe I should put like some big eyes. Only look at the domain. So when you're trying to decide if a function is continuous or discrete, you're only going to look at your x's. You're only going to look at your domain. Yay? So make sure you add it. And that is the only thing that I'm giving you permission to add so far, right? Yay? So far, we have all of this that we kind of did today, right? All this mumbo jumbo we did today in our class. So now you know where it's coming from. And now we have that discrete and that continuous. When we start writing, oh, we have the zeros, right? Which is the same thing as your what? X-intercept. Do you see it over there? It's really tiny, but does it say X-intercept? Yes, it does, right? All right, and then you know how to use this. The domain is the same as the X's. The range is the same thing as the Y's. And then next week, we're going to learn how to use this. And then the week after, we're going to learn about parallel and perpendicular and things like that, okay? So the rest of them that you still cannot recognize is because it's coming. Alrighty? So right now, we got all of this plus this, and then the entire front that you can use as cheat sheets, correct? All right. So let's go to here. So what was the domain in here? Tell me the domain. What was the domain? Okay, no. What was the domain? Was it the surface area or was it the side length? The side length, right? All right. So think about side lengths. This is a cube. This was talking about a cube, correct? Yay or nay? You with me? Yay? All right. So this is talking about a cube. Can you have a side length of 2.3? Yes, you can. Can you have a side length of 4? What about 4.5? Yes. So, is it counted or is it measured? It's measured, which means it's what? Continuous. All right. What was the domain in here? Number of people. Oh, that one's really easy. Can you have half of a person? So if you have people, do you have to count them or can you measure them? You have to count them, so it's what? Discrete. Discrete, right? Because you can't have half of a person. Yay? All right, let's go to the next one. Thank you very much. Domain and range is a lot of common sense when it comes to real world. It's just common sense. But my mother says that common sense ain't common. I think she's right. It ain't common. Not everybody has it, does it? All right. What was the domain over here? The shirts. Can you count the shirts or can you measure the shirts? One shirt, two shirts, three shirts, four shirts. So that would be what? Discrete. Yay? Can you measure the shirt? Can you measure the shirts? Like by size? Is that what you're talking about? But you still need to count how many small you got and how many mediums you got and how many large you got. So I would say that that's still counting. No le busque las 5 patas al gato. All right, what's the domain? What was the domain in here? Number of guests, right? So can you have half of a person? Okay, continuous means, yeah, we're getting confused. Eyes on me. Stop talking. This is continuous. 2, 2.1, 2.2, 2.3, 2.4. That's continuous, right? Yes, it continues. $2, $2.10, or if you want to go more specific, $2.01, $2.02, right? Counting means 1, 2, 3, 4, 5, and 6. This continues because you can have decimals, right? That does not continue. You have to count. So that means I got to say 1, 2, 3. See how I'm picking up my pencil? 4, 5. There you go. Right? I cannot count like that. Got him. There's 31. Right? Does that make sense or no? No? Yes? All right. So, when your number of guests, you can definitely what? Count them. So that would be discrete. All right? That would be discrete. Okay? Last two. All right. What was the domain over here? The number. All right. Let's think about it. Can you have half of a souvenir? No. So you need to say 1 souvenir, 2 souvenirs, 3 souvenirs, 4 souvenirs. Because if you have half of it is broken, and why would you want to buy something that you broke it? That you broke it. So that would be discrete. Shh, gentlemen. All right, what was X over here? All right. Very good, because you can have half of an hour, or even 3/4 of an hour, or even 1/4 of an hour. So this would be continuous. We got it. Okay? It really is, like Michael said, it's just a lot of common sense. And people not talking and paying attention. All right, so we finish all of that, put it back. All right, go to your family folders.